Hello learners, welcome. Previously, lesson 32 form 3 topic 2, we were dealing with back titration, aim number 1, which was determining the molar mass of the analyte. We have done example 1. So today, lesson 33, we are going to do example number 2. We are told 0.24 gram of a divalent metal Y dissolves in 50.0 centimeter cube of 0.25 molar sulfuric 6 acid. Full stop. The resulting solution required 5.0 centimeter cube of 1.0 molar sodium hydroxide solution to neutralize the excess acid. Then we are told what is the relative atomic mass of Y. Okay, to start, first of all, we have to know the number of moles of the sodium hydroxide that reacted with the excess acid. We can start from there. So we're going to say moles of sodium hydroxide. Moles of sodium hydroxide. The formula for calculating moles was molarity multiplied by volume used of 1000. So this will be 1.0 multiplied by 5.0, then divided by 1000. So this we are going to get 0.005 moles of sodium hydroxide. Moles of sodium hydroxide. So this is the number of moles of the sodium hydroxide that has been neutralized by the excess acid or the excess sulfuric 6 acid. So next step, we have to get the number of moles of the excess sulfuric 6 acid by writing the equation between sodium hydroxide and dilute sulfuric 6 acid. So we are going to have sodium hydroxide aqueous plus sulfuric 6 acid. Aqueous, we are going to get salt of sodium sulfate solution plus water. So we are supposed to balance the equation. We put 2 here and we put 2 there. That will be the balanced chemical equation. So let us get now the mole ratio between sodium hydroxide ratio sulfuric 6 acid. So the mole ratio here is 2:1. We have 2 in the side of sodium hydroxide and we have 1 hidden in the side of sulfuric 6 acid. So we know the number of moles of the sodium hydroxide that reacted with the excess acid. So that is 0.005. So we can ask ourselves, what about the number of moles of the sulfuric 6 acid? So this will be 0.005 times 1 divided by 2. This will be 0.0025 moles of the excess acid. The excess acid. The acid that we are talking about is sulfuric 6 acid. That will be the number of moles of the excess acid. Next, we are supposed to get the number of moles of the original acid or the original sulfuric 6 acid. Here we are given 50.0 centimeter cube of 0.25 molar sulfuric 6 acid. So we are going to write moles of original acid. Moles of original acid. That means the original sulfuric 6 acid. Okay, moles is given by molarity of sulfuric 6 acid, which is 0.25, multiplied by the volume, which is 50.0, divided by 1000. Here we are going to get 0.0125 moles of sulfuric 6 acid. So this will be the number of moles of the original acid. So next step, we have to get the number of moles of the sulfuric 6 acid that reacted with the metal Y. How do we get that? By subtracting the original moles of sulfuric 6 acid by the excess acid, the moles of excess sulfuric 6 acid. So we are going to get moles of sulfuric 6 acid reacted with the metal Y. This we can get by having the original moles of sulfuric 6 acid, original moles of sulfuric 6 acid minus the excess moles of sulfuric acid, the excess moles of sulfuric 6 acid. That will be the formula of getting moles of sulfuric 6 acid reacted with the metal Y. Okay, this will be equal to the original moles is 0.0125 minus the excess moles of sulfuric acid, which is 0.0025. This we are going to get 0.01 moles. 0.01 moles. So this will be the number of moles of the sulfuric acid that reacted with metal Y. Next, we have to get the number of moles of metal Y that reacted with the acid, that's sulfuric acid. So how are we going to get? We are going to write the reaction between Y, metal Y, with sulfuric acid. Okay, remember, metal Y is a divalent. It is given there. It has a valence of 2. So that means we are going to get Y sulfate solution plus water. I mean plus hydrogen gas, because when metal react with dilute acid, we are going to get salt and hydrogen gas. Okay, let's see the mole ratio, because this reaction is self-balanced. Y ratio sulfuric acid is 1:1. So we know the number of moles of sulfuric acid that reacted with metal Y, which is 0.01. So what about the number of moles of Y? This will be 1 times 0.01 divided by 1. So this will be it will be equal to 0.01 moles of metal Y. So next, we have to get the RAM, the relative atomic mass of Y. If you want to get RAM is just like the molar mass, and molar mass is given by the formula mass over moles. So RAM of Y will be equal to mass over moles. So the mass is given in the question. Check, you are told 0.24 grams of a divalent metal Y. So we're having 0.24 divided by the moles of metal Y, which we have gotten as 0.01. So when we put this in the calculator, we are going to get 24. That means that's the relative atomic mass of metal Y. And if you were asked the identity of that metal Y, that's automatically magnesium, because magnesium has a relative atomic mass of 24. That's the end of our question there. We are going to go to the second page. Here we have the extended question, and we are having our example 3. Try it, and you can give your answer on the comment section. Thank you.